Hi everybody, welcome to Test 2 review in Calculus 1. As always, you see the topics will be on the top. On that side we have some formulas. Right, let's get started. On the first topic, we see it is derive the derivative, and it is in the class note section 3.5. So we will not do that here. It is again in the section 3.5 about trigonometry, derivative of trig functions. Right. We start to find derivatives in general. Well, that will include a lot of formulas of derivatives. By the way, you will not have this formula on the test, so make sure you know those formulas. Say that again. This formula will not be provided on the test, and you need to know this. Right. So all of this will not be there. Right. So first, try to find derivative. This one obvious. It is a quotient rule. There's no other way. That is as easy as that. Alright, so the quotient rule. So let's start with the rule first. So the quotient rule is that the top is u and the bottom is v. So we write out u is x cubed v x minus 1. Then we take derivative of each one of them. Derivative of u is 3x squared v prime will be just 1. Right? Now derivative of this will be just the quotient rule. So we say derivative of y is going to be the quotient rule. So we do that. U prime will be 3x squared times v x minus 1 minus u times v prime is 1. All of that over v square. Right? And then we'll multiply it out. 3x cubed minus 3x squared minus x cubed and 3x cubed minus x cubed, we have 2x cubed minus 3x squared over x minus 1 squared. And that's all we have. We will not need to multiply the denominator out, and the top we don't need to simplify anything. So it will be just that straightforward quotient rule. Alright, so that is one. Right. Next, we go to 2. We have the power rule. over there on that side. So we can pretty much take any power. Here we have that a over x, so we can rewrite as a power, and to rewrite that, roll it up, we can use that formula to rewrite 8 over x. So we write a function as 8x to the negative 1 plus 10 second x. Now we can take derivative. X to the negative 1 is going to be negative x to the negative 1 minus 1 will be negative 2, and there will be the 8 in front of it, all multiplies. Derivative of secant, we'll need to know that for the test, but at this stage, that is the derivative of secant. Give us secant tangent. And that will be just that. On the test, that's good enough. As soon as we take the derivative, we don't need to simplify. When we find the critical points, then we need to worry about that. Right. Next, derivative of this. We know how to take derivative of tangent of t. We know how to take derivative of t to the fourth and square root of t as well. So first of all, actually, just take care of the square root of t. Still have t to the fourth and tangent of t minus t to the 1/2. So I haven't taken any derivative yet. That just rewrite the function square root of t as t to the 1/2. Right. Now we'll take derivative. Right. What we see is, again, we can take derivative of tangent t, take derivative of t to the fourth and t to the 1/2. However, since these two multiply together, we have to use the product rule. I will write over here. Derivative of the product. So now we take derivative. Since this is a product, so we'll have a product rule. Right? And then I have the minus. This derivative by itself, I would be just 1/2 t to the negative 1/2. So take down the 1/2, and the original power of 1/2 minus 1 is 1/2 minus 1 is minus 1/2. And then all of this is the product rule. Right? U is t to the fourth, v is tangent t, u prime 4t cubed, v prime. Derivative of tangent is secant square of t. Now just put in here u prime t to the fourth I mean u prime, right? For t cube. Sorry, that's u prime. V tangent t u t to the fourth and v prime secant square secant t square. Right. Not much we can do with this. We can factor out, but that doesn't do much. And that's pretty much it. So pretty much that's the answer. Again, we can just leave the derivative like this. We don't have to change to the t to the 1/2. We're going to do a lot of that later. We can move this to the bottom to the t to the 1/2 and that, but as soon as we get out derivative, that's good. Right. Next, derivative. This also obvious. It's a product rule. And the formula is still that, so I'm not going to write the formula again. We just need to write u equal to 5x and v sine x. U prime is 5, v prime is cosine x, right? And then we'll take the derivative of this. The question asks us for the second derivative though, so we need to take the first derivative. Right, u prime v. I can also write like that. Of course, you don't need to do exactly like I did here. I'm just going to write like that so we have easy to keep track of things. U prime v, u v prime. U prime is 5 v sine x, u 5x, v prime cosine x. So we're going to have 5 sine x and then 5x cosine x. Right. So that is derivative. And then we have to find the second derivative. I'll let you do that. Just check the derivative of this, and that is going to be another product rule. I'll let you do that problem. I'll let you finish this. Right, so we have those 3 questions. Right. There will be a lot more derivative involved in the chain rule, which will be in the next part of it. So again, you should finish this problem where we take the derivative one more time. Right. We get back to this problem, that is velocity and acceleration. We do not have the decomposition function. I'll just do one quickly. So we can, for example 7, we can put that in the box, and we have cotangent of the box, and the box is 7x minus 5. So we can say cotangent of, let's say u, and then u is 7x minus 5. Something like that will work. Wait a minute. Actually, need us to find the derivative. Sorry, I haven't read the question. We do need to find the derivative. So we have to do it. So now we do it. Right, 6. Find the derivative. Now, if we have the parentheses here, to the fifth will ignore whatever it is inside, and then we'll take the derivative. The derivative of apprentices to the fifth is going to be 5 apprentices to the fourth, and then the derivative of whatever inside the parentheses. So in this problem, it doesn't matter what we have inside that parentheses. Doesn't matter. We just do that. Now in this, what inside is negative 2x plus 7. That is what the problem has. And then so all of this is set up already. Now we just need to take the derivative of this, which negative 2x plus 7, derivative is negative 2. And multiply 5 and negative 2. And then we have negative 2x plus 7. Yeah. So we have 5 times negative 2 give us the negative 10. Right. 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 Next we have the parentheses, and the derivative of cotangent of a parentheses is negative cosecant square of the parentheses and then the parentheses prime. Doesn't matter what it is inside. So we just have that. Derivative of this is just 7. And then I move the 7 in front. The 7 and the negative is negative 7. So we just like that. Right. So this is the typical chain rule. Right. 8 and 9. That was 6 and 7. Right. 8 and 9, but we'll do some of it. I may not finish. So square root of 4x plus 2, we can pretty much put the parentheses around it. And then we see the square root of the parentheses. Why don't we write 4x plus 2 to the 1/2, because square root is equivalent to 1/2. Now we will take the derivative. Whatever inside the parentheses doesn't matter, because we just take the derivative of the parentheses to the 1/2. So we have 1/2, whatever it is, the parentheses, 1/2 minus 1, and then the derivative of whatever it is inside doesn't matter. We take the derivative. Derivative of this is just 4. Right. Usually we leave it like this, but if we just have one number for derivative of the parentheses, I will multiply with the 1/2 here. 4 times 1/2. 1/2 times 4 is going to be 2. And then we have 4x plus 2 to the negative 1/2. Right? I will not do number 9, but just have to move the 4 to x minus 3 to the negative 4 like that. It will be a lot easier now when we take the derivative with the parentheses. Will be 5 times negative 4, the parentheses to the negative 4 minus 1 will be minus 5, and then derivative inside. Right, I'll let you finish. Just need to put 2x minus 3 inside and then take the derivative and then simplify anything we can. Right, there will be more derivatives. Again, all of this formula we see here will not be on the test, so we will need to know the derivative of those basic functions. Right, 10 and 11. Right, hate when this happened. Right, this a little bit different. We see cosine to the 4th power. So actually what we see is we have to have the put that in different colors so it is easy to see. But what we do is we take the cosine first. And then we raise to the 4th power. Right. So that's what it is written. Now be careful when we take derivative. Now we don't just have the parentheses, we have the whole bracket. So the bracket to the 4th power, if we take derivative like that, will be 4 the bracket cube. So in general, that's what the derivative is. Now we take derivative of inside the bracket. Yeah. So as you see this problem, we use the chain rule twice. Now inside the bracket is this. And so we just repeat this. Check the derivative of the bracket. Now all of this will stay the same. Now focus on this derivative only. We have cosine of the parentheses. Now we still have a parentheses here. Cosine of a parentheses is going to be negative sine whatever is in the parentheses and then the parentheses prime. By the way, it is not subtract, so we should put a big parentheses here. We just that. So we have multiply the negative sign, then multiply by sine, because cosine gives us negative sine. And if we just write the minus in the middle, it looks like those two subtract, each other, but in fact it just multiply a negative sign and then multiply again. So just multiply by negative, really. Then pi t minus 11, pi t minus 11. Right. Now we have the minus sign here and the 4. We have minus 4, and then we have now focus on this only. The 3 is can go to the cosine, so we can write cosine cube pi t minus 11. Right, minus we already took care of that, and now we just have sine and then derivative of this. A derivative of t is 1, so pretty much we just have pi. Right, now we can also write the pi in front of this, so the almost find the pi times negative 4, so it's negative 4 pi cosine cube pi t minus 11 sine pi t minus 11, and there will be no more derivative, and we are done. Right, this problem we have to take use the chain rule twice, in form of the bracket and then in form of the parentheses. All of them just multiply all together, it's just one term. Right. The next problem kind of similar way. First we'll have the parentheses here, so it's fine, we start with that. So derivative of power rule is negative 6, the parentheses, negative 6 minus 1 is negative 7, and then derivative of the parentheses. Right, now all of this unchanged. Now derivative of this, now we focus on this derivative. Derivative of 1 is 0, so that's just that. And now we take the derivative of sine at. Now for this you actually have to put in another parentheses, because in the formula over there we only have sine of t or sine of x, this one 8 of them, so it's a little bit different. So we have to have cosine of the parentheses and then derivative of the parentheses at close. Right, now in this one we only see derivative of at is 8, so we have cosine of at times 8. Notice all of this are just multiplied all together, just one term. So all the constant can just put it out here so it's easier to see. All are multiplied. So we group the 8 and the negative 6 together. And that's what we have. Again, this derivative also, the chain rule, we have to do it twice. A chain rule inside the chain rule, that is. Right. So that's all the derivative, the main topic for this test. Next we have velocity, speed, and acceleration. So first, if we have s is the position function, I'm going to write a little note here. S is the position. V, velocity, obviously, is derivative of the position function. And then acceleration is derivative of velocity, or the second derivative of the position function. That is acceleration. Right. In the middle of that, we have the speed. The speed is the absolute values of velocity, meaning that it has no direction, it just has the magnitude. So we should say the magnitude, but if just one dimensional, it is just absolute values. Right. So we just need to take derivatives pretty much. Right. Read the question carefully though. They want the speed and acceleration at the end of the interval, meaning 2. Right, so first we'll take derivative. That is the velocity. So it will be negative 3t squared plus 4t minus 2. And then we put 2 into it because at the end of the interval it is t equal to 2. So at t equal to 2, let's see the calculator. Right. So I take 2, store into x, and then I just type this. The reason I use x instead of t because x is just one button to enter. Negative 3 x squared plus 4x minus 2. Much faster to enter that way. So it is negative 6. Of course, if we take the unit will be meter per second. However, we find the speed, not the velocity. So we will have the speed is the magnitude of v will be positive 6. And then the acceleration, sorry, there's no, I thought I have a y out. It's fine. So acceleration is derivative of the velocity, or the second derivative of the position function. So pretty much we take the derivative of this will be negative 6t plus 4. Now at t equal to 2, a equal to negative 6, 2 plus 4, so will be negative 8. Right, so we have 6 and negative 8. Right, so position, velocity is derivative, speed is the absolute values of velocity, and I should say magnitude. Acceleration is the second derivative. That better. Right. Next, we'll go to implicit differentiation. So what it says, implicit differentiation. We have dy over dx. So what we see here is we write y is a function of x. With that, we mean we're going to put the parentheses around y. Kind of difficult to see. Let me do that again. 2x y minus y squared equal to 1. Put the parentheses around y. Right, because y is a function of x. Now we take derivative. And then it's just like what we did earlier. Derivative of the parentheses square. If we take the derivative of this term, it's going to be 2 times, I should not do that, 2 times the parentheses, 2 minus 1 power, so just 1, and then derivative of the parentheses. So in general, that's what it is, because x is a variable. Now we have y and y. Derivative of 1 is going to be 0. So what we did here is we differentiate with respect to x. Right. Now what we see here is product rule, because we have x and then something x here. So that would be u, will be v. So we will end up being a product rule. The minus in the middle is still there. So let's write right, u prime v, u v prime. Right. U is 2x, v is just y. Notice y will carry a parentheses around it. Derivative of u will be just 2. Yeah, it doesn't have the parentheses because x is a variable, so we do just that. Derivative of y of the parentheses will be just 1, the parentheses square. Remain the derivative of the parentheses. Right. Will be just y prime. You can write as dy over dx, which is same as here. Right. Now put things together. U prime, that will be 2. V will be just y. U 2x v prime dy over dx. Right, so let me rewrite that. 2y plus 2x dy over dx minus 2y. This y prime, of course, is just dy over dx equal to 0. Right. Now both of them have dy over dx. This one doesn't. We will move the 2y to the other side, and at the same time factor out the dy over dx. right? If we factor out the dy over dx, we should have 2x minus 2y equal to negative 2y, and divide by the parentheses here, and we are done. On the test, as long as we have the dy over dx by itself for this problem, this is good enough. We can stop here. We can cancel the 2, but it's not necessary. Just gonna leave it like that. Or divide everything by 2 or negative 2. Right, so that. Next one, we still need to find y is a function of x, so we put the parentheses around it. Sorry, that was 11. Right, so we write again x to the 7 cotangent of y, which will be a parentheses. Right, and we take the derivative. Right. This will give us 7x to the 6. There's no parentheses or anything, so that will be that. Having said that, we can also write, if you put the parentheses here, we will just do derivative of that, which will be just 1. So because x is a variable, that's why we don't really need to do this. In spirit, we can always put a parentheses like that. In that case, pretty much everything is a chain rule. Right. Now, derivative of cotangent is negative cosecant square of the parentheses prime. Right, so we have y prime 7x to the 6 negative cosecant square, and then y prime, we can replace that by dy over dx. We don't need to, but since the question asks us for the dy over dx, probably it is better to just write dy over dx. Y prime is perfectly fine. Right, pretty much that. And divide by the negative cosecant on both sides, and we should have it. Right, so pretty much that. Of course, we don't put the negative at the bottom. So it will be like that. Over cosecant square, actually, we can also write sine square, but we don't need to do that. Right, for that 13. We did something very similar to 14. I will not do this, but what I do instead, it would be better if we square both sides, and we will have y square, and then the square root equal to 16. Square root, square cancel out. We have y square x plus 1 equal to 16. We can also multiply it out. Right? And then y is a function of x, and then we put the parentheses around the y, just the y. Then we take the derivative. That is the product rule. And then that we solve for dy over dx. What I do instead is 15. So I have an equation of tangent line. We start with, that is the first thing we start with. Right? Y minus y1 we can write in that form, or we can write that's just the y values, and that's just the slope of the tangent line, and that's just the x values. Now the x and y values, I give x1, y1 are given this point. So x1 is 2, y1 is 1. So we know those points already, just need to determine the tangent. That, of course, where the implicit differentiation come back. Right. Now the same thing, we assume y is a function of x. And then we take the derivative with respect to x. That also a product rule. And then the derivative of 16 will be just 0. Right. I will skip a few steps, and then we just say u is going to be x to the 4th. So we have u here. U prime, derivative of that, 4x cubed. V, y to the 4th. V prime will be derivative of this. Will be 4 parentheses prime. Sorry, this is y to the 4th, so 4 parentheses cube and parentheses prime. Right. So this will be 4x cubed y to the 4th and then plus this will be 4x to the 4th y cubed and then dy over dx. By the way, I need to read the question again. This one just want the slope. Find the slope. They don't want the tangent line. So we don't really need to do this. We do it when we ask to find the equation with tangent line, but look like not. Right. Then we put 2 in for x. We said that x equal to 2, y equal to 1, 4, 2 cubed, 1 to the 4th, 4, 2 to the 4th, 1 cubed. So that is 8 for 32 plus 2 to the 4th power 16 and 4 64. So dy over dx negative 32 on that side divided by 64 negative 1/2. Next related rate, we'll look at 16 and 17. Number 18, we did something similar to this in the class note. If we go to class note, we have the problem with the airplane, and we should be able to do the same. Right. 16 and 17. Right. Now on this, the first thing we'll see is assume x and y are function of t. So let's just copy the problem. xy plus x equal to 12. And we asked to find dy over dt. So we know all of them are function of t, so parentheses here, and here, and here. All the x and all the y. Right. Now we just take derivative. I'll do the easy one first. This one. Derivative of this will be 1 because just the parentheses, and then derivative of the parentheses. Just put x there for a moment. It's not perfectly right, but we'll fix later. 12 will be 0. Now both of them are parentheses, so it's going to be a product rule. Still inside the parentheses. Now we'll take derivative. Be just 1 and then the parentheses prime. Yeah, derivative of parentheses or just one variable. Just put x here. Which term x prime you can write as dx over dt, because after all t is a variable and x is a function of t. Right, same thing here. Will be 1, the parentheses prime. Y prime will be dy over dt. Yeah, in this case we should write like this because only t is a variable. Right. Then we'll have the product rule in front of it. U prime v, u v prime, u prime dx over dt, v will be just a y here. We're not taking derivative, so we just y there. U will be just x, again not derivative, so we choose x. derivative of v is dy over dt. Right, so that's what we have. Right, let's put this together. Y dx over dt plus x dy over dt plus that's just dx over dt equal to 0. We'll continue here. When we continue, we'll have dx over dt is -3, x is 2, and y is 5. X equal to 2 and y equal to 5. So we're going to put y is going to be 5. Dx over dt is -3. X 2. dy over dt, that's one we don't know. We're looking for it, so it's here. Dx over dt we know is -3 equal to 0. Now what we say is we have 3 terms here and we still have 3 terms. By that I mean do not combine all of this together, because the plus sign here it's just to combine the 2 terms. So we can multiply here -15 and -3 equal to 0, and then the -15 and -3, those things we can combine. That -18. Again, the 2 dy over dt we cannot mess with it, so just stay like that. Can move the 18 over divided by 2. That's what we can do. And then divide by 2, we have -18 divided by we should add 14 on both sides, and we should have +18 divided by 2 will be 9. Yeah, so be that. Yes, in the related rate problem, usually every variable are function of t. So in that case, we put the parentheses around it and take derivative. Next we go to 17. Let's run out of ink. Right. Now this is a work problem. By the way, I'm not doing 18 because that's similar to the problem we did in class. Right. So what we have is the equation. So let's just copy the equation. Now what we have is, in this problem we'll say that we asked to find dv over dt, meaning that everything a function of t, and that's the nature of related rate problem. We assume everything a function of t. By everything I mean v and p. So let's put the parentheses around it and then take derivative. This is pretty simple. It's not even the product rule or anything. We just have derivative, and this a little bit different would be 1/2 the parentheses to the negative 1/2, and then the parentheses derivative. Of course, in front of that we still have 1106. Right, here we have V, and here we have P and P. Right, now since both of them are function of t, I just write here differentiate with respect to t. So this we write dv over dt. By the way, that's what the question asks us to find, so it's perfectly there. 1106 divided by 2, 553, and then p to negative 1/2, and then dp prime, that will be dp over dt. Right, now we'll go back to the problem. We have when p equal to 43 psi, with that will be p, and we have the pressure changing at this. So pretty much we will have 553, p is 43 to the negative 1/2, and dp over dt is 0.162. When we do that, we should get whatever that is. I got 587.45. Sorry, negative 1/2. Focus on that. I got 13.66, and then the unit. Right, we already did similar to 18 in class, so I'm not going to do that again. Next we go to the critical points. Critical point 19 is too easy. Focus on 20, which a bit complicated. Right. So to recap, to get the, actually we haven't started, but the nature of the review, I assume that we know quite a few things. Right, so first we will take derivative. So to take derivative of this with the square root, I should write like that. Then we take derivative. Will be ax squared minus 128 x to the negative 1/2. Right, the derivative like that will be just fine. But what we need is equal to 0 does not exist. Every time we see the negative power, we have to take care of it first before we go to anything else. right? So we have that. Now we need one big fraction. So to get one big fraction, what we do is multiply the common denominator, x to the 1/2 on the top, x to the 1/2 at the bottom. Now multiply these two together. We will add the exponent. Actually, we do have that properties. This is way back there. I mean that. So we add 2 and 1/2 will be 5/2. Right, so it will be just that. One big fraction. That's what we go after. Right, after that, after we have the derivative, we'll do two things. We say derivative equal to 0 or derivative does not exist. Derivative equal to 0, which means the top is 0. This means the bottom is 0. Now this is easy. X to the 1/2 equal to 0, so x equal to 0. A power equal to 0 when the base is equal to 0. Doesn't matter what the exponent is, as long as it's not 0, of course. This we can move the 128 and divide by 8. 128 divided by 8 be 16. I forgot one important thing. Now when we take derivative here, the 1/2 go down, and I forgot that. So that is not 128, but rather 64. 64. Sorry. Again, take the derivative of that which should have the 1/2. And that is 64 divided by 8. So x to the 5/2 is equal to 8. And also it is ax. Really sorry. So that is 3/2 and 3/2. Sorry. Basic derivative for x squared ax and 120x to the 1/2 is that. I should have know from the beginning. Anyway, so this is x to the 3 half equal to 8. I will rewrite as x cubed square root equal to 8. That, of course, is this property over there. So I can square both sides here. And then we take the cube root on both sides. Notice, unlike the square root, the cube root does not require us to have the plus or minus. So we just have cube root. Which is 4. Right. Of course, I could do this problem again and edit the video, but I just want to keep this so you don't have to make the same mistake when you see similar problem. Anyway, so we have x equal to 0 and x equal to 4. That's not the final answer. We still need to make sure that the function is defined. So we'll check critical point. After we find derivative, the top is 0, bottom equal to 0, do not exist. We checked. And every time we check with original function. So when x equal to 0, clearly it's 0, so it is good. So it is defined, and x is a critical number. Now at x equal to 4, for y equal to 4 square minus 128 square root of 4. Of course, whatever that is, it should be defined because we do not have imaginary here. So it will be just like that. Right. Once again, sorry about that, but yeah, of course you can learn from my mistake as well. That's why I just leave it like that. Right. So again, critical points take derivative equal to 0, do not exist. Top is 0, bottom is 0, and then we check. Number 19 kind of like that, except it's a lot easier. We just take derivative equal to 0 and then solve for x. That's pretty much it. Right, let's see what's next. Next 21 and 22 for absolute max and absolute mean. 22 look a little bit more complicated, so I do 22. I did not do more example in the later topics because that's still fresh, and I did a lot. We did a lot of examples in class. So for this later topics, probably we just have one example for each topic, and that let you the other problem so you can practice. Right. Now this absolute max, absolute mean. Right. So we do the same thing. Most of this problem we will have the 2 steps, and on the test you need to have those 2 steps. The first one is we take derivative And then when we find the derivative, we find the critical point inside this interval. And we'll write negative 27 to 1 instead. So we take the derivative, and after that we find the critical points in that interval. So the derivative, actually this one is a lot easier than the other. Sorry. Derivatives, we have 2/3 x 2/3 minus 1 is minus 1/3. Negative exponent, so we need to have fraction. The 5 and the 2 stay on top, make it 10. This negative exponent goes to the bottom. So we have that, right? So we have derivative equal to 0, because that means the top is 0. And then derivative does not exist. The bottom is 0. Right, so 10 equal to 0 for the top. Of course we will have nothing from that, no solution. And 3x to the 1/3 equal to 0. Divide both sides by 3. X to the 1/3 is 0, so x equal to 0. Right. Next, we should check to make sure it is defined. But since the 0 is between here, we're good. We don't have to check. So it is on the interval of negative 27 and 1. And in that we have x equal to 0. Now, the difference between the absolute max and absolute mean when we do this is, for absolute max, absolute mean, we use the table. If it is local max and local mean, we use the sign chart. We will go, when we go to the number 9, the topic number 9, we will do that. But for here, we just have a table. And the table, we use original function. I did say original function. 5x to the 2/3. We have the boundaries, negative 27 and 1, the 0 in between. Right. Calculator. Right. We go to stat and edit. To put the list, we have negative, this negative 27, 0 and 1. On this we're going to put 5. Sorry, we should put the L, highlight the L2, then we can enter the function 5. Instead of x we use L1, and that raised to the power of 2 over 3. So instead of x we have L1, and to get L1 we hit second and then number 1. We see L1 on the top there. Right, so we do that. Hit enter. 45. Zero and 1, we have 5. So here the absolute max. and absolute mean. Yeah, sorry. Yeah, so absolute max is equal to, we say absolute max equal to 45 occurred at x equal to negative 27, and absolute mean equal to 0 at x equal to 0. Right. So that is an absolute max and absolute mean problem. Take derivative. Pretty much we find the critical points. The critical points should be in the interval, and then we just put in the table. We just do that. Right. Increasing and decreasing. I think we did this problem in class. It's one of the class note, class example. So we do 24 instead. The function is increasing or decreasing is the derivative. Right, so most of this problem we have two parts of the problem. The first part is take derivative and find the critical points, and the second part is find where it is open, increasing, decreasing. The question asks for the interval. If the question asks for the interval, we do not need to check the critical point. Critical points, as it says, is a point, so we do need to check with the original function, make sure it is defined, but it is not what we do. We don't need to do it. So first is the derivative, and this is the first derivative. So we do that for x cubed minus 36 x. 81 derivative is equal to 0. Now, that derivative equal to 0, derivative does not exist. Sorry, this one we don't have a fraction, so really don't need to do that. Equal to 0, so for x cubed minus 36 x equal to 0. I can do it by hand, but demonstration, so I need to use a calculator. It's a demonstration. An example, that is. Right, this I write none because there will be nowhere this is undefined. So this is defined everywhere, so we do not have anything here. Right. Because the calculator I have there is, I don't think they have the apps. Just the finance app, which is not what we need. Right. So I hit the app key, all the way down to a polynomial simultaneous equation. That should be that. Okay, and polynomial root finder, the first one, this qubit, so go to 3, order equal to 3. Either real or complex, and just keep it real. And then yeah, we don't need to do anything, just keep the power, the order equal that. Next, the coefficient we have 4, 0. If we use negative, it will be this key. And then 0. When we hit solve, we will have it 0, 3, and negative 3. We can certainly do it by hand, but I'll just show that we can use the calculator for that one. Right, next we will have the sign chart. Need a ruler. Right, x derivative, we have 4x cubed minus 36x. Right, there are 3 points here. So the points pretty much will divide the number line, and the test point will be in the middle. I'm going to do that. So we have negative 3, divide the number line here, 0, divide the number line, and 3, that. So we have 3 points, and so it will divide into 4 intervals. So we need to choose in between the interval. So test point, we have to choose between those two, be negative 4, negative 2, be 1 or 2, and then 4. So those are the test points we choose between the interval. I should say that. So the calculator as well. Put that over here. Right. So on the same right windows here, actually, stat and edit. So there. First we need to clear this. When we clear, highlight the list, hit clear, and enter. Do not hit delete. Just clear and enter. Clear and enter. Right. Now we have the points. Those are the test points. Negative 4, negative 2, 0, and sorry, there's no 0. There are 2 and there are 4. We can also hit the second and graph to go to the table, but the table like that, if we have a decimal number, it will not work. So this will work for decimal as well. Right. Now we enter this derivative, meaning that first we highlight the L2. Now we enter 4 L1 cube minus 36 L1. Right. We have to highlight L2 while we enter in this second L1, second one for L1, and then we hit enter. Right, so negative, positive, negative, and positive. Negative is decreasing, positive increasing, decreasing, increasing. So we write increasing. By the way, this question only asks for increasing, so we only need to write it is negative 3 to 0 and from 3 to infinity. If we want decreasing, that would be the other two interval, and this one always open, so always use the parentheses. Because it is an open interval, we do not need to check the endpoints. Right, so will be that is that. Right, so derivative equal to 0 does not exist. Those will give us the points divide the number line, test point in the middle, and then we'll test them. Right. Local extrema. This is local max or local mean. So most of this problem will have two parts. The first one is derivative. The second part is the sign chart. But on this problem, it is the local extrema, meaning a point. So it is a point. So we need to check the critical points. Right. Derivative for x cubed minus 4x. Right, equal to 0 does not exist. Usually if we have a fraction, then we have to worry about that. This one doesn't have fraction, so we have nothing here. Right. However, this one for x cubed minus 4x equal to 0. So in a sense, it is very similar to the last problem we did. But this time we do it by hand. It's very simple. We can factor out 4x. And then we have x squared minus 1. Which means 4x must be 0. Or x squared minus 1 must be 0. So we have x equal to 0. X squared equal to 1. So x equal to, then point here, get rid of the square root, there must be a plus or minus. Right, on this problem we do need to check for the points. Right, so we do x equal to 1, f of 1, if we put 1 in here, 1 squared minus 2, 1 squared minus 9. minus 10. And then for negative 1 we should get the same thing. Only our space here, so still check in here. For negative 1 we still have negative 10, and then we check for 0, we should have negative 9. So we put the values back to original function. So every time we check, we use the original function. Except on the sign chart, we use derivative. Right. So we have 3 points here, 0, negative 1, and 1. Just need to put them in the right order. All of those points we divide the number line and divide the tables. The test point will be between those numbers. I choose negative 2, negative 0.5, 0.5, and then 2. As mentioned before, you can also use the second graph feature to go to the table, but the table will not be able to handle the decimal easily. There's a way to do that, but setting up is a bit much. So I clear this to list. Right. Next we put those test points. This is negative 0.5, 0.5, and 2. And on the L2, we want to enter this 4 L1 cube minus 4 L1. So we have negative, positive, negative, and positive going down, up, down, and up. I mean decreasing, increasing. Obviously, if we go like this, we will have the minimum here, a maximum there, and a minimum here. So now we list everything. Don't need the calculator for now. So we have the local mean equal to something at x equal to negative 1. So when x equal to negative 1, we have negative 10. Next, the local max at x equal to 0 equal to negative 9. That's what the y value is at. That's why we check though, just find the y values. If the y values happen to be undefined, then we don't have the point. So that's what we have. So all of those, let me update the list first. All of this we using the first derivative, and those application after that we're using the second derivative. Right. Concavity, but still the same though. Most of this problem we have two parts. So use the second derivative. Right. 26 is a lot easier than 27, so I would look at 27. Simply just the derivative though. Right. Now we take the derivative of this. Second derivative, that is. I'm going to write like this. Right. Now second derivative. Hmm. 26 is similar to this, so the derivative is a lot easier to do. So we take derivative 3 and the parentheses like that, so be 3, take out the negative 1, and then we have the parentheses to negative 2 and derivative of the parentheses. So 3 negative 1 x plus 1 to the negative 2, and derivative of this be just 1. Now we have 1, negative 1, and 3. All of those multiply together give us negative 3 x plus 2 to the negative 2. Right, and then derivative again give us second derivative. Right, negative 3, take down the negative 2, and then the parentheses to the negative 2 minus 1, that's negative 3, and then derivative of the parentheses. That gives us 6. And derivative of x plus 2 is 1. Or just, you can write 6 over x plus 2 cubed. Right. By the way, this question we asked for the interval, which means we do not need to check for the critical point. If we ask for the maximum, minimum, critical points, inflection points, pretty much anything that have the y values in it, we need to check the interval, just the interval of x, so we don't need to check for y values. Right. Run out of space, but that's actually all the space we need. Second derivative equal to 0. Second derivative did not exist. That is the bottom equal to 0. Right. 6 equal to 0. Of course, we do not have anything there. This x plus 2 cube equal to 0. We do run out of space here. x plus 2 cube equal to 0, meaning x plus 3 must be 0. So we just have x equal to negative 2. Yeah. No need to check for the critical points. And I should not say critical point because this is from the second derivative. So it's not critical point, it's just points. Potentially it could be inflection point, but that's not the question. We don't need to do that. What we do need to do is the sign chart. We only have one point here, negative 2. Right. Here we have the second derivative, 6 over x plus 2 cubed. Right? We have negative 2 to divide the number line. Then we pick the point in the middle. By middle, not exactly in the middle, just any point inside will be fine. Right, put 0 in here. I can almost do this by hand. Put 0 in here, that will be positive. And that will be positive. And put negative 3 in here. Negative 3 plus 2 is negative 1. Cube is negative. So negative is concave down. Positive is concave up. Of course, we should remember this. Right. The question asks us where the function is concave up or where the function is concave down, depends on the question. But if it only asks for concave up, we'll give the interval where it is positive. Right. Our inflection point. Right. Inflection point. Just like as mentioned before, this question, if we ask for the inflection points, a point required to have the y values. So we need to check for, it's not the critical points, but we just say check for the points. I mean, need to do that. Right. Again, most of this question we have two parts. First is the second derivative. And then the sign chart. The sign chart is a little bit different. You say why we just have the inflection point, why do we have to check for the points? Because that needs the y values. But then why we have to do the sign chart? We make a lot more sense when we get there. First we check derivative 6x squared plus 24x plus 18. Right? Second derivative 12x plus 24. Second derivative equal to 0. Second derivative does not exist. Of course we have nothing here. So x equal to negative 24 divided by 12 is negative 2. Now we do need to check for x equal to negative 2. And every time we check for the point, we need the y values, and the y values come from the original function. Once again, minimum, maximum, inflection point, critical point, all of that require the y values, which means the original function. Right. I use a calculator for that. Right. I just store negative 2 into x, negative 2 store into x, and then we just have the second derivative. Check for the points, meaning the y values, original function. Okay, original function, this one, 2x cubed plus 12 x squared plus 18x is negative 4. Right. Remember, as earlier, we check for the point, we check for the y values, but actually we'll check for one more thing. It's on the sign chart. Second derivative right. This point I could choose a negative 3 and 0 here. Put in 0 here, obviously it's going to be 24, which is positive, and put in negative 3, it's going to be negative. So we have concave down and concave up. So to that question, why do we have to do the sign chart on this one, and what we are looking for? Right. So what we're looking for is the inflection point is where the derivative change the signs. So go from negative to positive, or from positive to negative. In this case, it goes from negative to positive. So it's good. The sign changes. So we say the inflection point will be at in between. At x equal to negative 2. In particular, when x equal to negative 2, y equal to negative 4. That's why we check to find the y values. And then the second derivative test, the last topic. We did a lot of this in class. 30 look more complicated, so we will do 30. Right. So second derivative test. So what we're looking for. First, second derivative test. The first derivative has to be equal to 0. So that will be a critical point. More detail like this, will be it's posted in the note already. So we need the first derivative equal to 0 critical point. Second derivative, if it's going to be positive, it open up, and open up can only have the local mean. Second derivative is negative. It opens down, and opens down can only have local max. And if it is equal to 0, the second derivative, that is, it will be inconclusive. Right, so that is the function. First we check the derivative. Will be 12x cubed minus 12x squared minus 24x. The point is given, which is good. At x equal to 0, right, that is equal to 0. Yes, so the first point here, check. So there will be 2 steps of the problem. Do that first, and then one of those 3 will pop up. So it is equal to 0, which means x equal to 0 is a critical point. Next, find the second derivative. What means from there? (36) x squared minus 24x minus 24. Right. At x equal to 0, the second derivative at 0 equal to 36 0 squared minus 24 times 0 minus 24, and all are zeros except for the last one. So this one is negative. Negative means it open down, and open down can only have local max. So we say x equal to 0 is a critical point, and it is also will give us the local max. Yeah, we just need to identify that it is a local max, and that will be good enough. We do not need to find the y values, because I believe the second derivative test is just a test, so it will tell us if it is the local max or local mean. We don't really need to find the y values. Right. So that pretty much we cover all the topics there's on the test too. By the way, on the first one, derive the derivative of tangent, cotangent, secant, and cosecant. That is in the note for section 3.5. We should look at that. And a problem on the related rate here. From with the airplane. This problem is related rate. I think that is section 3.9. Other than that, as I mentioned before, we cover all the topics on the test too. So I'm going to end the video here, and I hope it help you to prepare for the second test. The second test will be on this Monday. Also, we only have the Monday and the Wednesday, and then after that we have Thanksgiving. So next week we only have Monday and Wednesday, and no class on Friday. Right. As always, thank you for watching.